So by popular demand, and by that I mean Matthew on my last video, so hopefully this helps you at least, we're going to do a video on how to do quick inverted hull outlines on characters. And this method's really simple, so in some cases it's not going to work on more complicated characters. You'll have to, you know, your mileage may vary. And this is probably not a very performant way of doing this. Just throwing that out there. So if you're super performance focused or maybe on mobile, like it may or may not be a good idea. It is, however, really fast and simple, and it works for at least some of the models that I've found on the marketplace. The reason I'm showing you on this model in particular, I'm not a character artist. I don't know how to animate anything like that, but I needed to get a character that animated effectively. Like you can see the Amber model here from Genshin Impact. It has outlines, but it's not animated, and there's some issues with this method. Uh, they don't stop it from working. It's just that it's a bit more complicated, and I don't fully understand the animation side of things. So I needed a model that was animated that I could try it on. And again, it doesn't work on all of them. Your mileage may vary. At the end of the video, I'll show you an issue with a model that I had from the Paragon Epic. Um, all those models Epic put out on the marketplace for free. Okay, so we're just going to go over some things that are kind of like fundamental to understanding how the method works. If you don't want to know any of this stuff and you just want to see how the blueprint is set up, skip to the timestamp. I will try and put one on the screen if I can figure out how YouTube works. So, you know, here we have a cube, right? And there's eight. Wait, no. 6 sides. Six. Okay, so there's 6 sides. They're quads, and you know, in theory, they're rendered as triangles, but like, you know, but it's not really important right now. So, uh, each of these faces has a normal associated with it, and if you don't know what a normal is, it's just the mathematical kind of definition for the vector that the surface is facing. So, like these are the normals for those faces, right? And they're the same across the whole of the face because they're not smoothed. So when you're rendering something in 3D, the 3D engine, the rendering engine is actually not. They're only rendering one side. They're doing what's called culling, and for example, the other 3 sides that are behind right now, they're not being rendered because it knows that we can't see them because they're facing in the opposite direction. Ignoring the fact that they're farther in the Z direction and being covered up by the front faces, they're just not being rendered. So, like for example, we can't do that actually. So if you go into the object and you select all the faces, you can flip them. So now you can see it's kind of like it's like a diorama setup. But all those faces still exist. They're just not being rendered. You have the like these faces here. What you do have are the new normals for these faces are facing towards us so we can see them, and the old normals are facing away from us, and they're just, the rendering engine just decides that they don't need to be rendered and skips them. So the way we take advantage of this to do outlines is we're gonna unflip the normal so we just have a box again. We're gonna duplicate the box, make it a tiny bit bigger, move it back into approximately the center. And now if we take this new slightly larger box and flip the normals, and we'll give it a black material just to make it look outliney. Now we can see the inside of the larger box, but not the front of it. So we get a full 360 outline around the box. Okay, I'm just going to start right in the Unreal Epic Games Launcher store, whatever it's called. Delete the previous version of this that I had. We're going to do everything completely from scratch. We're going to launch the engine. We're going to make a game. Set the third-person demo just because it's convenient for this. Name the project outlines. So we're doing blueprints. The quality settings don't really matter. You can do whatever you want. We don't need starter content, but all that's up to you. Okay, so here's the third-person blueprint. or a template, whatever you want to call it. You can jump around as the mannequin character. We don't want him, so we're just going to delete him. So we need a character. We could do this with the mannequin, maybe. I haven't tried with him actually, but whatever. We'll go with the coolest stylized character. So in the Epic Games store, if you go to the marketplace, search for, I think, Mixamo. There we go. There's a Mixamo animation pack. It's free. You can download it. Just click. There used to be a free button here, but just click this and add it to projects. We'll show you. So now I have it in my library. If I click add to project, nothing comes up because I don't have any 4.10 projects, but if do show all products, and then that's the current one, and we can just change that to 4.10. It's fine. It works fine. So that's now added to our content folder, the Mixamo animation pack. It gives us a bunch of characters. We're going to do the Maw because I think he just looks the best with the outline look. We're just going to drag him into the scene so we can see him. And if you click G, you can disable all the little icons and stuff. So now, though, if we click play, we're still going to get the mannequin. We don't want that. So what we're going to do is in world settings on the right-hand side, under game mode override, go to third-person game mode and select the selected game mode default pawn class. Change it from the third-person character, whatever the default is there, and select the Maw or whichever character. Now if we click play, we get this guy, and he can run around and jump and attack. Okay, so we're just gonna leave that there so you can see him on the screen. So we need to go into the actual Mixamo Maw blueprint and make some small changes here. It gives you a warning about this being a data-only blueprint. That's fine. Just you can still open it in the editor. You just have to click the Enable Full Editor button or whatever it said there. So we're going to go in and select the mesh for the character. And what we're going to do is duplicate it and just call it outline. So in this character, for whatever reason, the original mesh is offset by a couple of location and rotation values. So like this, the duplicated one starts at 0. I don't know why. You have to copy over the rotation and location values from the original mesh onto the new one so that they line up, and I'm just going to skip through that because it's just copying and pasting a couple values. So now that's done, you can see the meshes don't actually line up properly. That's just because every time you move them in the viewport here, it resets the animation cycle on them. But if you hit compile or save, it'll reline everything up. So that's the character. Everything looks about right now. So we just need to actually set this outline mesh material to a new mesh or a new material we're going to make. Call it M outline. And with the outlines mesh selected, not the main character mesh, change the material to this new material we made. And do compile again to line everything up there. Okay, so that's all we need to do with the blueprint. We can now open that material that we just made, and we're going to change a couple of the details settings here on the left. Material domain surface is fine. Blend mode we need to change from opaque to masked, and that basically just gives us alpha control with this opacity mask here. And shading detail model, we don't need it to be lit. We can just set it to unlit because it's just going to be a black outline. And we need to set two-sided to be enabled. So what we want to do is flip the normals of this mesh so that it's only rendering the inside and not the outside. What that's going to give us is kind of a shell where we're only seeing the main model and then the back of all these black polygons. So there's actually a node for that. It's called the two-sided sign. And what that gives us is it's going to give us a positive one for the outside and a negative one for the inside. I'll do it with the emissive color really quick to show you. So here, this white, that means 1. And if we scroll in, that black is going to be a negative 1. It gets clamped down to 1 to 0 to 1 anyway, but for the math, it's 1 and negative 1. If we're doing an opacity mask, the alpha, a 1 is going to be something that's shown, and a black is going to be something that's not shown. What we want to do is have this plugged into the opacity mask. That's not going to make a difference right now, but hold on a minute. What we want is the outside to be black, and that means it's not going to be rendered, and then the inside to be white, which means it is going to be rendered. So if we put that into a 1- node, put that into the opacity mask, now you can see we don't actually get anything, but if we were to erase, or if we were to hide the main character mesh, you would see that there would still be a black kind of silhouette of the character there. We can hide him for a second just to demonstrate. So select that character mesh and then disable him. So you see that shadow is still kind of left over. So all we really have to do to make an outline is make that shadow slightly bigger than the original character. And there's a pretty simple way to do that. There's just a node for vertex normal world space. There's one for vertex normal, vertex tangent world space. Don't click that because that's a different vector. And if you just put that directly into world space position offset, it actually expands it a little bit by default. And you can see now we already have an outline. So you can leave it at that, but there's a couple of other things we want to kind of have control over. The easiest thing is to just multiply this by some amount. You can make a new scalar parameter by holding S and just clicking anywhere. We'll call it width, so it'll control the width of the outline and multiply that. And it'll just scale all those vectors along their world normal by some amount. So 0 is obviously going to be nothing, and then 1 is going to be what the standard was when we just plugged the world normal vertex normal directly into the world position offset. And then we can just scale that to whatever we want. You can see there's some artifacting going on with these floating meshes. There's not really any way to avoid that. The way to avoid it would be to set up a more thorough version of this shading and exclude these little meshes that are kind of floating. But also, like, you kind of would want them anyway. So it's really just when you're designing the model, you want to take into account that you're planning on doing this, and you want to have bold shapes, not many floating little pieces of geometry all over the place. Because this is going to work with smooth, bold shapes best. Any little intersecting pieces of geometry are going to look kind of weird. So we're just going to set the width for now as 1.6 something. Seems fine. So that's really the entire shader. If we just save all this stuff, we can go in and actually play around, and you can see everything just kind of works. All the animations are good. Everything syncs up. So I'm going to show you one other adjustment you can make here. I noticed it in some of the games where you have outlines that are done in this style. They do a system where the closer the camera is, the smaller the outline is. So like if we go way far away, for example, you can see the outline almost disappears. You can still see maybe the remnants of it around the antlers there, but you know, it becomes a lot less defined. So if for whatever reason you want to go with that art style and you want that to be more pronounced at a distance, I'll show you there's an easy way to do that. We're going to move this over here, and there's a node called camera position world space. And we're going to get the actor position. Now, if we take this and do a distance calculation on it, that's going to give us the distance between the two things, the actor and the position, or the actor and the camera, sorry. Now, if we take our width, we can multiply the distance between our width. We're going to have to change the width in a second, you'll see. The value is going to be different, but you can just change it to whatever it works out for in your scene. And we're going to clamp this. Actually, I'll show you later. I'm going to change this first because it looks really weird. It's going to be a really low value in this case, 0.001, something like that. And plug that into the world position offset. That might be too small. Oh, hang on. That's all wrong. Oh, you know what? I'm silly. We want to plug that into the multiply there, and then the world position offset. There we go. That'll be better. Yeah. So now as we get farther, you can see relative to the size of the model, the outline gets like huge. And it just keeps getting bigger the farther we get away. So first of all, this number's too big. This width needs to be even lower than it was. Oh. It's going to be a very small value in this case, something like 1.00. Here I have, sorry, 0.007 in my example. So even that's a pretty thick. Well, I guess it gets thinner the closer you get, which is what we wanted. So, but as you get farther away, you can see it's kind of, that's even probably a bit too big, but it gives kind of a neat effect because at medium distances, it's kind of, that looks pretty good, but then the closer you get, like the borders don't become overpowering. But obviously at far distances, it gets to look a little bit silly, so we're going to add one more feature here. And we're just going to clamp the value to a minimum and a maximum so that it doesn't get out of control. And the example I have, like what I've set up with and tested, is a value of 0 for the minimum and a value of 3 works well. For the maximum, that is. So there. So that's as small as the... well, that's actually as big as the outline gets for being far away. So there's a little bit of an outline. But then as you get closer, it does kind of max out. So that's all. That's all there is to it. You can add probably some other complexities to make this shader work differently. There's one thing I am going to show you. And this is what I did on that amber model, and I think it looks good in a lot of cases, depending on the style you want, though. So right now this border is black, obviously, which is probably what I would go with for this character. I mean, it looks pretty good, but if you plug the emissive color into the texture for the actual character, right now it'll look a bit silly. Hang on. Like now it almost looks like there's no outline, right? But if we multiply this by some amount, let's call it tint because it's going to make it darker. Put that into emissive color and set this to anything between 0 and 1. Like 1 will just give us the same texture. And so that's kind of not helpful. But if you put this to like 0.3 or something like that, it creates a darker border, but it kind of matches the color. So you can see it looks kind of better for the things like hair. This, again, works better on really stylized models. Like the Genshin Impact model, it's pretty much flat colors, so you can see here the hair texture, and that ends up being a little bit weird. It still kind of gives a neat effect, and it might work better or worse depending on the model you have. So I lied, but that's all there is to the shader. Now we're done. I want to show you one of the kind of drawbacks of this method, because it's not going to just be a straight drag and drop this material and this mesh onto some character and make it work every single time, because it depends on how the model and character were developed. So with that Mixamo pack, it's going to work and everything should be fine. Maybe not for all the characters. I haven't tried all of them, but it, is very easy. It takes a couple minutes to plop on the outline. I tried with one of the characters from the Paragon packs first, because I don't have a ton of experience doing this with actually animated characters, so I wanted to try how it works. So this is a character from the Paragon characters pack that Epic Games released, and you can see he's got outlines on him. He's, he looks really good. He's obviously not a kind of stylized character where I would recommend using this necessarily, but yeah, he's kind of Borderlands-y, I suppose. And this works all good. You can jump around, and his outline stays mapped to the same animations. But if you attack, it gets completely out of whack, and I have no idea why. I'm not terribly surprised. This is one of the things that I'm not sure about with this method, so your mileage absolutely will vary between characters, but I don't know how to fix that with this character. So with modern, really complicated character setups, this might not be as simple as just dragging and dropping it onto the character and having it work with every single animation. Especially if you have some kind of physics cloth simulation going on, I can't imagine that this exact method would work the same. You can still do the inverted hull somehow, it's just that it won't work this way exactly. So the other downside of this method is you're effectively tripling your poly count depending on how the engine handles two-sided faces. I assume there's some optimizations, so it's probably not quite as bad as tripling, but it's at least doubling, right? Because you have that main mesh that's duplicated once to create this outline shell, and so that's 2 times right there. But then the way that engines generally handle two-sided polygons is they just treat them as though they're 2 separate polygons facing opposite directions. So again, might not be 3 times, but it's definitely a performance hit to some extent. But I would basically say don't worry about it, because modern graphics hardware chews through polygons so fast that just increasing the polygon count of a model, even by a pretty significant margin, isn't really going to tank performance. This isn't a fair scene to demonstrate that because it's so simple, right? But you know, just work within a reasonable budget. And if it ends up being too high poly count for your model, then you can reassess later. And again, the correct way to do this is to go into your 3D package and create the shell, which is still going to double your poly count, but go into the 3D package and create the shell in there, and then it's only going to be one-sided polygons. At the very least, you'll get a little bit of a benefit.